Hello, my wonderful people. Welcome to today's math class. Again, we want to have some fun here solving this math challenge here now. The question is m times m all over 2 times 2 equal to 2 times 2 all over m times m. What is the value of m that will satisfy this equation here? I solved a similar challenge of this kind already on this channel. I'm going to leave a link in the description below where you're going to have an access to it. But in that regard, we have about 3 of the variables up here and the 3 of that same variable down here. Then 3 of the constant up here, 3 of these constant down here. In other words, we solve for 6 good roots to that challenge. But here, it is obvious that we have to solve for 4 roots. So what are the 4 solutions to this math challenge here? So before going to today's challenge, if you're new here, this is OnlineMaths TV. If you've not subscribed, please do us that great favor by subscribing. And when you subscribe, hit the notification bell so that you get notified whenever we drop an amazing video like this very one you're about to watch right now. So with that being said, let's go into today's challenge. Okay, so we take our solution first thing first, according to Steele R. Carvel. All right, so we just have to what? Rewrite this, and rewrite this. And so this automatically will give us m to the power of 2, and this is 2 to the power of 2. This is equals to 2 to the power of 2 all over our m to the power of 2. Easy, right? Good. Like I said in the previous video, we could as well say we should cross multiply, but we want to use the right mathematical term or the right mathematical jargon here. So we want to multiply this side by m to the power of 2 and also 2 to the power of 2. Then we also multiply this side by m to the power of 2 and also 2 to the power of 2. So let's go ahead and do that. This will give us m to the power of 2 all over 2 to the power of 2 times our m to the power of 2 there times 2 to the power of 2. Let's put this in bracket, everything equal to our 2 to the power of 2 all over m to the power of 2 times our m to the power of 2 times 2 to the power of 2. Let's put this also in bracket. Now, what do you observe? This will go with this, then our m to the power of 2 will go with m to the power of 2 here. Right, so we are now left with our m to the power of 2 times our m to the power of 2. This is equal to our 2 to the power of 2 times our 2 to the power of 2. Easy. Look at the variable we have at the left-hand side of our equation. They are of the same type or kind. And we have a multiplication sign here. So there is a law in indices which says that if you have your a to the power of m times your a to the power of n, said take one of these base number and add this together, which is m plus n. If we apply this rule, then we're going to rewrite this and this. So this is going to give us here our m to the power of 4 equal to 2 to the power of 4. Easy. Okay. Again, if you observe carefully, the powers are the same. And we have an equality sign. And so we may be tempted to say m is equals to 2 as the final answer. But is that the only answer? No, we have 3 other roots that will satisfy this equation. How do I get to know about that? Because our variable is raised to power 4. And so it shows that we have to solve for 4 roots, although 2 is one of the roots. So how do we go about that? We just have to move this to this side of the equation. So this is going to give us our m to the power of 4 minus our 2 to the power of 4 is equal to 0. Now we are having m to the power of 4 and 2 to the power of 4. Do we have a difference of fourth cube or fourth power? I have not seen that. Maybe we may have something of that, but yeah, we want to simplify this into a simple terms. We want to break this into 2 times 2, break this into 2 times 2, so that we can have what we call difference of 2 square. So we can go ahead to rewrite this. According to the law, we say that if you have your a to the power of mn, this is equal to your a to the power of m bracket your n. So if we consider this very law here, we can rewrite this and break the powers down. In other words, we can have this to be our m to the power of 2 bracket 2 minus our 2 to the power of 2 bracket 2 equal to 0. Now, with what we have here now, we have what we call the difference of two squares, which says that if you have a all to the power of 2 minus b to the power of 2, this is equal to your a plus b, or a bracket a minus b, right? Now, you remember this very one? But we made use of this law in so many of our videos. So from here, I want to rewrite the whole of this expression in this format. And so this now implies that our m to the power of 2, then plus our 2 to the power of 2, close bracket, then bracket, our m to the power of 2 minus 2 to the power of 2, everything equal to 0. Here we equate this to 0, we equally equate this to 0, according to the zero product law. And so doing that, this is going to give us our m to the power of 2 plus 2 to the power of 2 equal to 0, or our m to the power of 2 minus 2 to the power of 2 equal to 0. Easy. Now, if we take the first one here, which is our case 1, so let's take this as our case 1. If we take this as our case 1, then we go to write m to the power of 2 plus our 2 to the power of 2 equal to 0. Here we apply what we call the sum of two squares. What does it say? It says that if you have your a, all right, to the power of 2, then plus our b to the power of 2, said this is equal to bracket your a plus b I iota, the bracket your a minus b iota. This is what we call sum of two squares. And so we now apply this to solve this easily, right? Okay, so what does that mean? Our expression here could be written as bracket our m, then plus 2 iota, bracket our m minus 2 iota, close bracket equal to 0. So here again, we have case 1 of star. Okay, so let's take case 1 of star. Then what does it say? We're going to have here m plus our 2 iota equal to 0. So send this to this side of the equation. So this is going to give us our m is equals to minus, so minus here, okay, so minus 2 iota. So we're taking this as our m1. So this is the value of our m1. All right, minus 2 iota. Now let's take our case. Let's take our case 1 star. So what is it we have here? To be our m minus 2 iota equal to 0. So send this to this. This is going to give us our m2 is equals to positive our 2 iota. So we'll solve for 2 good roots to our m here now. And again, I said we have 4 roots to solve for. So let's consider our case 2 from where? From here. Look at our case 2 here. So let's continue on this side of the board. See what this gives us in turn. Now let's take our case 2, right? Case 2i. Now what is our case 2i? So this is our case 2i. So we're going to have our m to the power of 2, then 2 to the power of 2 equal to 0. Here we apply what we call the difference of two squares, which is what we'll look at here already. So this is going to give us here m plus our 2 close bracket, then bracket our m minus 2 close bracket equal to 0. Apply the zero product rule, which says that we equate this to 0, equate this to 0. So this is going to give us m plus 2 equal to 0, or we have our m minus 2 equal to 0. So here we have m is equal to minus 2, or our m equal to positive 2. So we have two roots from here. So therefore, we can now say here our M3 is equal to minus 2. Then our M4 is equal to positive 2. All right, so these are the other two roots to this challenge here. So in all, we have our roots. So we cannot say in all, our M1 is equals to, look at our M1, minus 2 iota. Our M2 is equal to, where's our A2? Positive 2 iota. Our M3 is equal to negative 2, and our M4 is equal to positive 2. So these are the four roots to this math challenge here. Look at what I said the other time, that if we said that since the powers are the same, we can equate the base, then we're going to come up here with positive 2, and of which is one of the roots to this math challenge. But look at the other three roots. Okay, these are imaginary. This is a negative. So this brings us to the end of this math class. I believe you must have learned something from this video tutorial. And whatever you must have learned from the video tutorial, drop it in the comment section. You must have maybe observed an error or an omission, then drop it in the comment section. We're going to reply to you swiftly. We are there to reply to you. Okay? Now, this is OnlineMaths TV. And again, I want to bring a soft reminder to you that if you've not subscribed, subscribe to our YouTube channel so that the algorithm can push our videos to more people. Thank you for watching OnlineMaths content amidst of millions of math videos on the YouTube. Remember, we love you dearly. Bye until we see you in our next class.